The parallelogram law of vector addition states that if two vectors acting simultaneously on a particle are represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, then their resultant is completely represented in magnitude and direction by the diagonal of that parallelogram drawn from that point. Now, let me explain this law. Now, what the parallelogram law of vector addition is saying is this. If you have an object or a particle, let's call it particle O, and two vectors are acting on this particle at the same time. Okay? So two vectors are acting on this particle at the same time. It could be two forces. So one vector is acting this way, the other one is acting the other way. And you can represent these two vectors by the adjacent sides of a parallelogram. So let's say a parallelogram looks like this, okay? So it means this is one of the vector, this is the second vector. Okay, so if the two vectors we are talking about is vector A and the other one is vector B, and both A and B can be represented in magnitude and direction. What does that mean? It means the length of A represents the magnitude of A, and the length of B represents the magnitude of B. So if you can represent two vectors acting on a particle at the same time by the adjacent sides of a parallelogram in magnitude and direction, then the resultant vector of the two vectors, in this case A and B, is represented in magnitude and direction by the diagonal of the parallelogram drawn from their point of intersection. So this one is the resultant vector. Okay? Now this resultant vector, the length of the resultant vector represents the magnitude. That means the length of this line represents the magnitude, while the arrowhead on top represents its direction. Just the way the length of vector A, that's the length of the line, represents the magnitude of vector A, and the arrowhead on the line for A represents the direction for vector A. Then the same thing can be said about vector B. This is what the parallelogram law of vector addition is all about. So it states again one more time that if two vectors acting on a particle at the same time can be represented in magnitude and direction by the adjacent sides of a parallelogram, A and B in this case, then the resultant vector of A and B can be represented in magnitude and direction by the diagonal of a line drawn from the point of intersection of vector A and B. Let's talk about how we can apply this to solve problems. Assuming you have two vectors acting on a particle at point O, okay, and the particle in question is at point O. Now let's say the two vectors are vector A and vector B, and the angle between them is, let's say, theta. Okay, now according to the properties of parallelogram in mathematics, if the angle between them is theta, then this angle here will be 180 degree minus theta. Okay, that is one of the properties of a parallelogram. Then of course this side will be vector A and this one too will be vector B because opposite sides are equal. Now the resultant vector, according to the parallelogram law of vector addition, when you have two vectors that make up the adjacent sides of a parallelogram, is the diagonal of the parallelogram. So I'm going to use the letter R to represent the resultant vector. Now there are two ways you can calculate the resultant vector. Number one, you can use what we call scale drawing. Scale drawing involves the use of scales and sometimes you have to use a graph paper to calculate the resultant vector. The second method, or the second way you can go about calculating the resultant vector, is using what we call the cosine rule. Now, if you take one of the triangles in the parallelogram and you make a sketch of it, so let me just make a sketch. Now this is just a sketch, so it's not drawn to scale. Of course, this is vector A, and this other one is vector B. Then this angle is 180 degree minus theta. Okay, then this is the resultant vector. Now the cosine rule is a rule that is applied to triangles. Okay, you can use it to calculate the side of a triangle. You can also use it to calculate an unknown angle in a triangle. If I apply the cosine rule to this triangle, it means I'm going to be writing the square of the horizontal vector is equals to vector A squared plus vector B squared minus 2 times the product of vector A and B multiplied by the cosine of 180 degree minus theta. Now this is the cosine rule when applied to this triangle. Okay, it's a rule you must have done in mathematics, and if you are yet to do it, I'm sure you are going to do it very soon. Okay, now after calculating the magnitude of the resultant vector, you need to still calculate the direction. To calculate the direction, you have two options. Option one, you look for the angle the resultant vector makes with vector B, or option two, you look for the angle the resultant vector makes with vector A. Both options will not give you the same answer, but that doesn't mean any of them is wrong. Okay, take note of that. So let's take an example using numbers this time around. Now for an example, let's assume that two vectors are acting on a particle simultaneously, and the particle is located at the point O, and let's say one of the vectors is 3 Newton and the other one is, let's say, 5 Newton, and the angle between them is, let's say, 60 degrees. Now if the angle between them is 60 degrees, based on one of the properties of a parallelogram, this angle will be 120 degrees because both angles have to be supplementary. Okay, so if this is 3 Newton, the side opposite it will also be 3 Newton. Then I can say the same thing about the side opposite, the 5 Newton, that will also be 5 Newton. Then I'm looking for the resultant vector, so I'm using letter R to represent that. Okay, like I said some seconds ago, you can take one of the triangles, so I'm just going to make a sketch of that. Okay, so I have my 3 Newton here, I have my 5 Newton here, I have the resultant vector, then the angle between them is 120. How did I get 120? You do 180 degrees minus 60 degrees, so you get 120 degrees. Okay, now if I apply the cosine rule, I'm going to have the square of the resultant is equals to 3 Newton all squared plus 5 Newton all squared minus 2, then you have 3 Newton multiplying 5 Newton multiplying cos 120 degrees. Okay, now the next thing you are going to do is you take your calculator and you run this. By the time you do this, you are going to be getting 49 Newton square. Make sure you get 49 Newton square. Okay, then you do for the square root of 49 Newton square. Okay, square root of 49 will give you 7. Square root of Newton square will give you Newton. So the magnitude of the resultant vector is 7 Newton. The next thing we are going to do is we need to talk about the direction. So in talking about the direction, I'm going to either look for the angle it makes with the 3 Newton vector or the angle it makes with the 5 Newton vector. So let's take one of them. Now let's say I want to look for the angle the resultant vector makes with the 5 Newton vector. So let me call that angle let me call it alpha. Okay, so I want to look for the angle alpha. Okay, now I'll quickly do a sketch of the same triangle. This is 120 degrees. My resultant is known now, so I'm going to put 7 Newton there. So I'm going to put 3 Newton here. Don't forget the arrows. Then I'm going to put 5 Newton. Okay, now I'm looking for this angle alpha, the angle the resultant makes with the 5 Newton vector. To find this angle, I can decide to use cosine rule again, or I'll use a simpler rule, what they call sine rule in mathematics. Now, what's sine rule? This is physics, but let me quickly tell you what sine rule is all about. If you have a triangle, let's say you have a triangle A, B, C, and this is side B, side C, side A. Then the sine rule is a side over the sine of the angle facing the side is equals to another side over the sine of the angle facing this side, and is equals to another side over the sine of the angle facing the side. Okay, now you take any two at a time. You don't use the three of them at the same time in most questions. So I'm going to apply it to this now. So I'm going to take 7 Newton, which is a side, over the sine of the angle facing 7 Newton, which is sine 120 degree, is equals to, I'm looking for alpha, so I'll focus on the one that has to do with alpha. So I'm just going to do 3 Newton over sine alpha. Then you can make alpha the subject of the formula. So you're going to have 7 Newton multiplied by sine alpha is equals to 3 Newton multiplied by sine 120 degree, what some people call cross multiply. So your sine alpha will be equals to 3 Newton times sine 120 degree. If you divide both sides by 7 Newton over 7 Newton. Okay, Newton can cancel Newton here. Then your alpha will now be the sine inverse, or some people call arc sine, 3 times sine 120 degree over 7. So if you use your calculator to do this like I'm doing right now, though you can't see me, so you try and do it. Okay, so if you use the calculator to do what I'm doing right now, meaning you do 3 sine 120 degree, then divided by 7, they do shift second function depending on your calculator. Some calculator will not have shift, some will have they will have something else, okay, for you to activate the arc sign. So whatever calculator you use, just be convinced that you're going to get alpha is equals to 21.8 degree. So now that is the angle the resultant vector makes with the 5 Newton vector. Now, like I said, a vector has magnitude and direction. We have looked for the magnitude. We got 7 Newton as our answer. And we have looked for the direction, and it makes an angle of 21.8 degree with the 5 Newton vector. In some cases, you don't just say it makes an angle of 21.8 degree with the 5 Newton vector. You start using any of the northwest, northeast, southwest, or southeast direction to describe what your answer is, depending on the question. If you have any question, you can ask me through any of the platforms made available. You know them, okay? You can contact me through any of them. Thank you for listening.